This is going to be a short video. I think you will find the exercises here are very easy. So today we're going to talk about exponential equations. So first of all, we need to define a rule. So we're going to start with a rule. This is very important. This rule is what's going to take us through this whole lesson. So if you have an equation with an exponent of x, or even an expression in the x, and you have another equation with the same base, with another expression or number in the exponent, you can actually eliminate the bases by saying that x equals k. This only works with exponents that have the exact same base. The a's have to be the same, and you cannot have anything else in the equation. Everything must be in the exponents. So let's start with some examples. Please make sure that you write this rule down. So first example is 2x, or 2 to the x power, equals 16. So can we write 16 as a base of 2? All right, so we can write 16 as 2 to the 4th. This becomes 2 to the x equals 2 to the 4th. That means that x equals 4th. Simple, right? But of course, it wouldn't be that simple. We need to do some more complicated examples. So this one's a little more complicated, but not too much. 3 to the x plus 2 equals 1 over 27. Okay? We're going to be looking for powers of 3. So I'm going to leave 3 to the x plus 2 the same, but let's manipulate this fraction. So 27 is the same thing as 3 to the 3rd, but we can't have the fraction there, so we will actually utilize negative exponents. So we're going to make this 3 to the negative 3 equals 3 to the x plus 2. So now we can say that x plus 2 equals negative 3. Works out very nicely. I can now solve for x, and x becomes negative 5. Okay, so that was a simple problem. Let's do another one. So I have 4 to the x equals 8. Again, we're going to have to change both of these. I can't make 4 a base of 8, and I can't make 8 a base of 4, so we're going to change these to base 2. So instead of saying 4, I'm going to do 2 to the 2x, and I'm also going to change 8 as 2 to the 3rd, which now changes our problem to 2x equals 3. And I solve x equals 2 over, other way around. That's what I get for doing math in my head. X equals 3 over 2. Okay, if you're having trouble understanding where the 2x and the 3 come from, go back to the rule. Okay, the rule says that we have the same base, that we can then equal the exponents to each other. All right, let's do another one. I have 9. This one's a little more complicated. So the x minus 2 equals 1/3. Okay, now obviously the base we're looking for here is 3. So I'm going to change 9 to 3 squared to the x minus 2. And I'm going to change the 1/3 to 3 to the negative 1. But we're still not quite there. We have to make sure that these exponents are properly displayed. So we're going to change this. We're going to move parentheses around. We know that this 2 needs to be applied to both the x and the negative 2. So we're going to change this to 3 to the 2 parenthesis x minus 2 equals 3 to the negative 1. So then I have 2 parenthesis x minus 2 equals negative 1. Now I can distribute and solve. So it becomes 2x minus 4 equals negative 1. I add 4 to both sides and I get 2x equals 3. Hey, I have the same answer as before. X equals 3 over 2. Alright, so far I hope you found this fairly simple. That was it. I thought there was more examples. This is a short lesson. So your homework will be at Unmodo. No above and beyond. Make sure that you did your exponential homework as well. Or not your exponential homework, but your factorizing homework as well. And I will see you after Eid. Have a great break.